Okay, so 4-48, Lexi claims that she can send 14 text messages in 22 minutes. Her teammates, Kenny and Esther, are trying to predict how many text messages Lexi can send in a 55-minute lunch period if she keeps going at the same rate. So let's see. Is the relationship between the number of text messages and time in minutes proportional? Why or why not? Well, we know she sends the text at a rate of 11 messages for every 22 minutes. Okay, so that being said, it makes sense that if she had no time in 0 minutes, she would probably send 0 texts or 0 messages. Okay, so also knowing that it's a steady or the same rate, we're going to go ahead and say that it is proportional. So yes, it is proportional because the rate is constant. Also, at 0 minutes, she would have sent 0 texts. Okay. So let's take a look at part B now. So B is saying, Kenny represented the situation using the table shown below. Explain Kenny's strategy for using the table. Well, we talked about how if the rate's the same, if it's proportional, then the values can double. Both variables can double. So in this case, we're seeing that now instead of the 14 messages, can you realize that if you have the time, it makes sense that she would also send half the text, okay, because it's a proportional rate. Okay, so let's see. Now Kenny wants to figure out the 55 minutes. Now we have to figure out what Kenny's strategy is. Well, it looks to me, I'm trying to relate this now. We're multiplying things together, and it looks like I can multiply 11 times 5 to get the 55 minutes. In other words, now we know in 11 minutes we'll send 7 messages. So it makes sense that if we multiply that by 5 times the amount of time, she would send 5 times the amount of text. So 7 times 5, it makes sense that she would send 35 text messages. Okay. So it looks like Kenny is multiplying the number of minutes by 5. He will also multiply the number of messages sent by 5. Problem using an equation. Help her write an equation to determine how many text messages Lexi can send in any number of minutes. So to do this, recall that when we write equations, we want to make sure we have the let statements. So let's define our 2 variables. The first one that changes is we're going to say let t represent the time in minutes. And we're going to go ahead and say let x represent, actually, you know what, let's go and say let m. Let m represent the number of text messages sent, okay? So let's go ahead and write a statement relating how the number of minutes and the messages sent. So let's take a look at the messages and minutes that we that Kenny came up with. 7 messages in 11 minutes. Hopefully it makes sense that we can make a statement saying that the number of text messages sent is equal to the rate she texts, let's say types, and how many minutes she texts for, she types. Okay? In other words, instead of saying the number of text messages, we could use a variable. We could use the variable m. M is going to equal the number, the rate at which she types. So the rate is really just the messages sent per minute, right? So in this case, she sent 7 messages in. So she sent 7 messages in 11 minutes. That's the rate. 7 messages in 11 minutes. Okay, so if she sent, so we'll go ahead and write that here: 7 messages in 11 minutes. Okay, and that's going to be multiplied by how much time has passed, so times t. Okay, so this will be the, sorry, let's go and do that again. Why is that not erasing? So this will be the equation that we could use. Okay, so as far as finding the missing value in Kenny's table, we already did that. That was 35 messages in 55 minutes. Okay, we found that earlier in parts B. Okay, so let's go and solve Esther's equation. Will she get the same answer as Kenny? Well, Esther's equation we can't solve if we have two unknown if we have two unknown variables, but we have a known variable. We know that it takes her, we're looking for the 55 minutes. So we know what t is. We know how much time has passed. We know that t equals 55 because 55 minutes have passed. So let's go and use that equation. I'm going to go ahead and rewrite the equation Esther came up with. M equals 7 over 11. I'm not going to write messages over minutes times t. Okay, we are going to go ahead and substitute t for the 55. Okay, so I'm going to rewrite this as m equals 7/11 times 55. Now let's go ahead and figure this out. 7/11 times 55. Let's see, 55 times 7. 5 times 7 is 35. 5 times 7 is 35 plus 3 is 38. So we're going to have 385 over 11. Now we'll go ahead and divide 385 by 11. So that's 333. So we'll have 55 remaining. So it'll be the 35. So m equals 35. So we do get the same solution, the same answer, 35 messages sent. Okay, so what's the unit rate? That's how many text messages can she send in 1 minute. Okay, and that's, let's go ahead and use this equation again. M equals 7/11 times t, but instead of t, the time is now 1, because remember, unit rate means for every single unit, okay, for every increase in units, so times 1. So 7/11 times 1 is going to equal 7/11, and that's going to be the unit rate. The unit rate is 7/11. So she can send 7/11 texts in 1 minute.